13D number 3. Alright, 13D number 3 says solve for an angle that is between 0 and 2 pi. So in other words, the angle we give, we're going to give it in radian measure, and it has to be somewhere within one spin in the positive direction. First one we're given a, 2 cosine squared of x minus 5 cosine x minus 3. Alright, these questions are a little bit different, but when you look at it, hopefully you saw this. You're like, something squared, then the same thing, not squared, and then the number. Well, if you kind of saw that with your quadratic eyes, you would notice this is in quadratic form. Alright, so I'm going to do a substitution just to make it look a little more like a quadratic. I'm going to say let a equal cosine x. So cosine x will be replaced by a. So I'm going to rewrite my equation like this. 2a squared, because here we had cosine squared, and I'm making cosine a, so it's a squared. Here that cosine is replaced with a. So 2a squared minus 5a minus 3. That definitely looks like a quadratic equation. It's equal to 0, so we can factor and solve that. I'm factoring here. So let's see. When I factor it, I did the long method here. You can use whatever method you're comfortable with for factoring. I'm using grouping. I end up with 2a plus 1 times a minus 3 equals 0. Now that we have two factors, we can use the zero product rule. Zero product rule tells us that something times something, if two things multiplied make 0, then each of those things has the possibility of being 0, because that's the only way you can get a product of 0. So 2a plus 1 might be 0, because that will create 0. So 2a plus 1 equals 0, or a minus 3 equals 0. Solve this one all the way, you get a equals negative a half, and here a equals plus 3. I'm sorry, I don't know why I put that, 3. So negative a half or 3. But that's a. The problem's dealing with cosine though, so now I have to take those and substitute the cosine back in. So this, instead of saying a equals negative a half, I can say cosine x equals negative a half. And this one, instead of a equals 3, we can say cosine x equals 3. So here's two possibilities. First of all, when does cosine equals negative a half? Cosine is our x value, so when is x negative a half? So these are positive x values, these are negative x values. And when is it negative? Well, right here. This is negative a half right here. So there are two possibilities, this spot here or this point here. Those will both have a negative x value of a negative a half. And half tells you that if this is a half, then this angle here is 30, that means this must be 60. And that means this must be 60 here as well. So we're dealing with 60. 60 is pi over 3, right? Because pi is 180, 180 divided by 60. There's 3 60s that go into 180. So to get to here, how many times do we do a slice of 60? One slice of 60, two slices of 60. So 2 pi over 3 will get us here. And then we need to go beyond that to get to here. So this is 3 pi over 3, and then an extra slice, so 4 pi over 3. Alright, so 1, 2, 3, 4 pi over 3, 4 slices of 60 gets us here. And that's our 2 points. That's two things that meet this condition, negative a half. Can we go in negative direction? No, because this domain says between 0 and 2 pi. So it's saying stay between 0 and 2 pi. That means stay within one spin in the positive direction. Alright, now let's look at the second part that we had. From the a equals 3, we had cosine x equals 3. Cosine x, so when is cosine equal to 3? On our unit circle, there can never be a value greater than 1, right? Because this point, an x value of 1, this point has a y value of 1, this is negative x, negative 1, and here's a y value of negative 1. So the biggest values you can get on here are 1. So over here would be a positive x value of 1, but it's saying find when x is 3. If x is 3, it would be off this circle and out there, 2 units beyond there. It's beyond our unit circle, so there's no solution to that. Let's look at b. In b, we begin with 2 sine squared x plus 3 sine x plus 1 equals 0. Alright, I'm going to make the substitution again because I see this and I'm seeing a quadratic. Alright, so let a equal sine x. So replace sine x with a. That becomes 2a squared here. This becomes 3a plus 1. Again, this is a quadratic. I'm factoring by grouping. And I end up with a plus 1 times 2a plus 1 equals 0. Again, we have two factors. Set each one equal to 0. A plus 1 equals 0. 2a plus 1 equals 0. Solve that. A equals negative 1. Solve this. A equals negative a half. Two possibilities. And again, a is not really what we're dealing with. A in the beginning, we let sine x equal a, so we're going to put sine x back in here. Sine x equals -1, and sine x equals -1/2. So we're looking for sine, which is a y value of -1. There's only one place on the unit circle where y is -1. And this is -y, and here's -1. So this is the only spot where y equals -1. And there's only one spot on the unit circle. No, that's wrong. And there's a few spots in the unit circle where y equals -1/2. So I go here, here's a y of -1/2, here's a y of -1/2 also. Two locations for that. So let's deal with this one first. How do we get to this spot here? Well, if you spin this like this is pi, and then we have an extra half pi, so that's 3 pi over 2. 3 pi over 2 gets us there. So one angle that gives this situation is 3 pi over 2. And on the second situation, sine x equals -1/2, we're going to get two different angles to get those two negative y values. First, how do you get here? This is a half, so that means this angle must be 30. So we were talking about 30. There are 6 30s in 180, so we're dealing with the pi over 6 situation. So to go all the way around here would be 6 slices of pi over 6, and then one extra slice to do 7 pi over 6. So 7 pi over 6 gets us here. And then to get to here, we go all the way around pi, and a little bit more to get to here. To get to here, if this is a half, then this angle must be 30. That means we're almost a full rotation around, which would be 2 pi, but we're one slice, 1 pi over 6 slice short. So full rotation would be 8 pi over 6. I'm sorry, 12 pi over 6. So if we're one short, we have 11 pi over 6. So we go all the way around, 11 pi over 6. 12 pi over 6 would bring us to 2 pi. So 11 pi over 6. So those are two situations right there. Okay, let's look at the last one I have here, which is C. Begins with this equation, tan squared x plus 2 tan x plus 1 equals 0. I'm going to do a substitution again. I see a quadratic. Let a equal tan x. Replace tan x with a squared, 2a plus 1. So a squared plus 2a plus 1 equals 0. Factor this into a plus 1. A plus 1, this is a perfect square. Solve either of those for equal to 0, you get a equals -1. So that means tan x equals -1. Let's take a look at that. Tan x equals -1. So where is tangent -1? Again, anytime you see a -1 for tan, you should be thinking of two numbers, because tan is always y over x. So two numbers y over x, when you divide them, they get 1. So the two numbers must be the same. The only time y and x are the same is when we have root 2 over 2 and root 2 over 2. So that means we're dealing with a 45-degree angle. Okay, so on this one, to get a negative value, one of these has to be negative. So here, as you see, I have a root 2 over 2 y, negative root 2 over 2 for the x. Divide those, you'll get -1. And in the fourth quadrant, we have a positive x value, negative y value. So positive root 2 over 2, negative root 2 over 2. For tan, you would divide those, and you get -1. So these are the only two possibilities to get tan of -1. So first, how do you get here? You have to spin it like that. Since we have root 2 over 2, this must be a 45-degree triangle or angle here. And when it's 45 degrees, 180 divided by 45 is 4. So we're dealing with slices of pi over 4. To get to here, 3 pi over 4. To get beyond there, over here, 7 pi over 4. Because we're 1 pi over 4 slice short of 8 pi over 4, which is 2 pi. So 7, see 1, 2, 3, 4, 5, 6, 7 pi over 4. So two answers are 3 pi over 4 and 7 pi over 4.